conditional probability. The probability that the second event B occurs given that the first event A has occurred can be found by using this formula. So this notation represents the probability of event B given that the A already happened, and it is equals to the probability of A and B divided by the probability of A. So in this situation, we can refer to this Venn diagram. To find the probability of B, given that the A already happened, would be the intersection divided by the probability of A. So now we see the example. Example 14. A box contains black chips and white chips. A person selects two chips without replacement. If the probability of selecting a black chip and a white chip is 15/56, and the probability of selecting the black chip on the first row is 3/8. Find the probability of selecting the white chip on the second row given that the first chip selected was a black chip. From this example, we just need to take the information as follows. First, they give us the probability black and white equals to 15/56. And then the probability for black chip is 3/8. And then they ask us to find the probability of selecting white chip given that the first chip was a black. So the solution, since the question asks us to find the probability of white given that black was the first, so we take the intersection between black and white, which is 15/56, and then we divide by the probability of black, which is 3/8. So we get the intersection between B and W is 15/56, and then we divide with the total probability of B, then we get the answer. In this section, I will explain about the fundamental counting rule. In a sequence of n events in which the first one has k1 possibilities and the second event has k2 and the third has k3 and so forth, the total number of possibilities of the sequence will be k1 times k2 times k3 until kn. So for example, we have a sequence of two events. We toss a coin and then we roll a die. To find the number of outcomes for this sequence of events, we need to consider the total possible outcomes for each event. For a coin, we can get head or tail. For a die, we can get from 1 until 6. Therefore, to find the total number of outcomes for the sequence of these two events will be 2 times 6, then we get 12. Another one is factorial formulas. For any counting number n, the n factorial, which is represented by this symbol, equals to n times n minus 1 times n minus 2 until times 1. So let's say we have 3 factorial. So the 3 factorial equals to 3 times 2 times 1. And then if we have 5 factorial, we will get 5 times 4 times 3 times 2 times 1. And 0 factorial always equals to 1. Using the factorial formulas, we can get the concept of permutation. Permutation is an arrangement of n objects in a specific order. There are two rules. The first rule, we use the formula of NPR. If we have n objects and you want to permutate r objects, or you want to take r object from n with a specific order, then the formula is n factorial divided by n minus r factorial. Or you can just simply use your calculator, find the symbol of capital P, and then the total object. Let's say we have 10 total objects, and then you want to take 5 of them to permutate into different order. So you can press in your calculator 10p5. And then rule number 2 is applied when we want to find the number of permutations of n objects when several objects are identical. Let's say we have a chord with 1, 1, 2, 2, 2, 3, 4, 4. So we have several numbers that are identical or repetitive, or a password or a word. Example 16. A radio talk show host can select 3 of 6 special guests for her program. The order of appearance of the guest is important. That means we need to select 3 out of 6, and the order is specific. How many different ways can this be done? Okay, so obviously they consider the order, so we can use permutation. So we can put 6p3 in calculator and you get the answer 120. The next one is how many permutations of the letters can be made from the word statistics. So we need to count how many letters from this word first. So we have 10 letters, and then we need to consider what letters they are repetitive. So we have 3 T's, and then 2 I's, and then 3 S. And then the permutation for this problem will be 10 factorial divided by 3 factorial, 2 factorial, and 3 factorial. And then whenever you want to calculate the number of permutation in your calculator, don't forget put bracket for the denominator. And then you calculate this and you get the answer 50,400. And then lastly, if we want to select several distinct objects without we get to order, that means the order is not considered in our selection. So we use the concept of combination. So the number of combinations of R objects selected from N objects, we use NCR. So this is the formula. So you can use the NCR straight away from your calculator. So as an example, the director of movies at the park must select 4 movies from a total of 10 movies to show on movie night at the park. So the order of the movie is not important. So how many different ways can the selection be made? So from this simple example, we can straight away put 10C4 in your calculator, then we get the answer. And that's all from me in this video. So please do tutorial 3 for more exercise. Thank you.